All right. Hello, everybody, and welcome back. I am back tonight. I am feeling much better. Unfortunately, had to take the night off last night. Was feeling pretty terrible, but I'm good to go tonight, I think. So we will be picking up where we left off, actually, on our extra day, which was Tuesday, which wound up being the first actual, I guess, kind of makeup stream indirectly. Anyway, so we're going to pick up with some more asset system stuff tonight. We're going to discuss a point that's actually come up on the Discord server, if you guys have seen that. We'll discuss that briefly, although we're not going to action it just yet. And we'll continue on implementing the last couple of asset types we have here. I think it was shaders we have to convert, bitmap fonts, and system fonts. And then audio we're actually going to hold off on, at least for a little bit. So, with all that said, before we jump into too much of that, I do want to just take a quick second and thank the supporters of the channel, beginning with our partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are Dustin Punt, Gabby Bashir, and Gerboles Inc. I would also like to thank all the other supporters listed here. They are a combination of the other tiers of support on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It helps me cover expenses with running this project and the channel, equipment costs, and so forth. So thank you very much for that. I greatly appreciate the support. And of course, I appreciate the support of you being here, whether you are joining us live here on the Twitch side or the YouTube side. We simulcast both. Or if you're just catching the VOD later on, thank you very much for being here. Without each and every one of you guys, this project would cease to exist. So thank you very much for being here. I appreciate you guys. All right. With that said, this is an interactive stream, so I do like to interact with you guys in chat and so forth. So if you want to just say hi or whatnot, feel free to jump in chat and do that. Speaking of which, Dr. Elliott first, congrats on that. How are you doing tonight? It's good to see you. Ruche, hello. All right. So, where we left off last time is we actually wrote the serializer / deserializer for our scene, and I believe we actually set up the asset handler and registered it. So now we basically just need to repeat that process for our shader. And if I recall correctly, we did get kind of started on that, discussing what we're looking at here on the screen. We were talking about converting the file format of that. And so what we actually are looking at here is the sort of KSIN version of that, which is our own sort of storage format, where we have our individual attributes and uniforms and things like that that are listed here. One thing that I was considering doing was in this uniforms sort of this uniform setup, we've got a lot of repeated data here in the scope, and I think if we're gonna change this, maybe now is the time to do it, right? So instead of maybe repeating this every single time, I was thinking maybe we convert uniforms to sort of be an object, and then within that object, we then have our scopes. So we might have something like global equals, and then that's where our array of globals would sit, right? So these happen to be in the right order for this, so I can actually just kind of scroll down here, do this, and then say after that we'll have instance, right? Scroll past that till we get to our local section, and then do local, right? And so these are for our scopes on our individual uniforms, right? And I think that way we can actually just remove the scope line, and it makes this a little bit less verbose, right? So I suppose I don't really have to do this, but I suppose I could tab this stuff over as well. So we have all of that. right? So we can just kind of go through here really quickly and remove all of these various scopes. And I think it'll just make it a little bit easier to work with. So we don't have to sort of define that every single time. We can just sort of define it once and then go from there. So let's go ahead and move those ones over. Get this one too. I don't have an auto formatter for this this file format yet, so you'll have to bear with me there on that. I'll have to sort of do it manually. All right, but yeah, that feels a little bit cleaner to me. Hello over on YouTube. How are you doing? I am feeling much better this evening. Thank you. Yeah, so for those of you who are wondering what was going on with me last night, every once in a while I get these allergy attacks where my immune system basically just goes bananas. You know, my sinuses clog up like crazy. My eyes continuously just water. My nose continuously just runs. And that happens for about 24 hours. And it doesn't seem like any sort of any amount of allergy medication stops it. I take 2 allergy medications every day on the regular. And then when one of these things hits, I take 50 of Benadryl, and then I also take I have like nose stuff that I use. I use saline solution. I've tried neti potting. I've tried all of that different kind of stuff. And it just, you know, nothing really stops it, including like prescription grade stuff. So usually what I have to do when one of those hits is I just have to put my head down and wait for it to go away. I have to wait it out. So it doesn't happen very often, thankfully. Especially out of allergy season, but it does get me every once in a while. And so it lasted until probably almost about noon today. I was still, even when I woke up this morning, I was still feeling a little bit like on the brink of having another one, but thankfully it's cleared up now. So I appreciate the kind words and concern from you guys over that. Definitely appreciated. Let's see, I don't know how to pronounce that. Is that quercetin? I've not heard of that one, but I will look that up. Thank you for the suggestion. I will look into that one. I will look into those indeed. Yeah, like I said, it's not something that happens very often. It's once every few months, right? But like every once in a while, it just gets me, and there's not really much I can do. So, all right. Lou the Coder, you have sinus infection? Yeah, I get that. All right. So thankfully that's over and done with for today. Okay, so what we have here, I think this is going to be our final format. I am declaring this as version 1. I'm not going to have backwards compatibility with the old version. Just because I don't see the need at this point. You know, we kind of did that with scenes just to kind of exercise that code, but I'm not going to do that across the board, right? I'm going to do away with sort of the old method of parsing this stuff, and we're just going to use casein for the whole thing. Okay, so we talked about asset pathing, where we have the ability to have this. We're going to do away with the fully qualified names. We talked about that a little bit too. So I guess before we get into this, the other bit that I wanted to briefly talk about, actually, you know what? Maybe I'm going to wait until a little bit more people file in. I'm going to wait on that. You guys who are in the Discord server do know what I'm probably referring to, but yeah, I'll hold off on that. Would you ever add an OpenGL backend to the renderer? I might. I haven't decided yet. Is this engine, is it 3D or 2D? It's 3D. I mean, theoretically, it could be either one, right? It depends on how the application configures it. I'm developing everything to be 3D centric, though. So dropping a 2D layer on that would be fairly trivial at this point. Technically, we already do both because we do have a UI layer that is all 2D. So, yeah, we already technically do both. We don't have some of the things that you might expect a 2D engine to have yet. like sprites and that kind of thing, but eventually we'll be adding that stuff. So it should be fairly trivial to add that stuff as we need it. Is there going to be a game editor too, like Unity, Unreal, etc.? Yes, but it'll be a little bit more limited to that. We are going to write an editor, probably not for the first game, until we have a chance to exercise engine features. But yeah, we are going to write one. Artist-friendly interface. So not initially. Eventually, I'd like to make it that way, but not initially. From like, good to see you. Yes, I was doped up yesterday. It was really bad. Like, you can't take 50 milligrams of Benadryl and not be in a coma, right? But yeah, it's really cool stuff. Yeah, it is going to be neat stuff. I can't wait to work on that layer, but it's a little bit premature to do it now. But we are going to do it. Okay. So I don't see anything else in here that needs to change, so I think we can proceed with the parser. So what I'm going to do is I'm going to keep this file just sort of off to the side here so that we can see it as we write our parser. And I'm going to base the parser, I should say, I keep saying parser, I mean serializer. I'm going to base it again off of our, let's see, I'm probably going to base it again off of the height map serializer. Because the scene has like a little bit too much stuff in it. It's kind of the same concept, but I'm going to base it off of this one because it's a very simple one that also parses a KSIN file. And so that's what we're going to build out of this. So let's go ahead and I'll just make a copy of this file, paste it, and we'll rename this to, let's go with shader serializer. K-asset shader serializer. There we go. And we'll copy the C file too. And same thing. There we go. And we will open up this file. And we'll do a find and replace, replacing height map. In this case, it's just height map for some reason. It's not height map terrain, which actually is a little bit weird. I think I might rename that in a minute. We're gonna replace that with shader globally. Oops, globally. There we go. So there's that. And then let's actually jump back to the height map terrain serializer for a second. I actually do want to rename this. Clear highlights here. This should be height map terrain serialize, and this should be height map terrain deserialize, right? And then I'm probably gonna have to open up the C file and do that as well, because unfortunately the rename does not work if you don't have all the files open that it exists in. So, which is kind of dumb. I do recognize that. I wish the refactor was a little bit better about that. But there we are. We should probably go to the assets handler. Asset, not handler, assets system, rather. That's going to be in the C file. And let's see. Oh, okay. We do have that correct there. Oh, right. It's going to be inside of this guy. That's right. So let's see. We want... Let me close this. Asset handler, height map terrain. Yeah, this is going to be wrong. That's what I thought. Okay, so let's just do terrain and terrain. There we go. Okay, so that's fixed. Let's go back to our shader serializer. Right, so let's go to shader serializer C. And I think I'm actually going to do a sort of double rename on these guys. So I'm going to rename this to height map since we're basing it off of that. I'm going to do this, and then I'm going to go to the next function and do the same thing. And I'll show you why here in a second. Because now, globally on the file, we can do height map underscore terrain. And it will replace that stuff across the board. Okay. There are going to be a couple of messed up things here at the top as you're used to seeing. We have not actually created our K-asset shader type yet, so we need to go ahead and create that. And that's basically going to be a collection of these properties. So what we're writing here is basically going to take this file, or the contents of this file rather, not the file itself, and be able to serialize to and from this format to that new structure that we're going to create. So we'll go to K-asset types, and we'll go all the way to the bottom. And it does not look like we've actually created any of the structures for this, so we need to do that. Let's go ahead and take a copy of this first and go to the bottom. And so we'll need a string representation of this. So this is just going to be asset, whoops, not asset, shader. And then this will be shader. And then we'll type def a struct. We're going to call this K-asset shader. Right, and then we're going to have a K-asset base in here, and then we'll go ahead and declare our properties after. Looks like we've got some comments here, so let me go ahead and just catch up with that. Let's see. I don't even know where to start. I do a bit of Python for VFX. So, I mean, as far as where to start, you just kind of pick a spot, right? Like pick out what you want to do, or what you think you want to do, and start researching that thing. Start researching what language you should use for it, right? I can't say that I would use Python for a large game engine project, but you know, if it's what you know, maybe research if there's anything out there like Pygame or something like that that you could use to make a simple game just to get your feet wet. But yeah, if you want to get you know, more into it, you're gonna probably want to learn a language like C or C++. But yeah, that would generally be where you start with that. Don't take programming advice from the Hat Man. The Hat Man. Who is the Hat Man? Gotta go for now, but following on Twitch as well. I appreciate that. Thank you. CG Rockstar, thank you for the follow. Let me catch up on chats over here on the Twitch side. Timps, how you doing? It's good to see you. Give a good luck shout today. I appreciate that. You stream at the worst hour for me, so I never get to watch. Yeah, I know. You know, that's the reality of having a full-time job, right? Is I'm limited as to when I can stream. It is what it is. For Rio, yes, I am much better. I appreciate that. Thank you for asking. Yeah, much better today. I was official. Thank you for asking. I am feeling much better. Little question, if you don't mind. What's the purpose of the VFS? Is it mainly for asset management? So one thing that we don't want our engine to ever have to worry about is where an asset is located on disk, for one thing, right? We don't want to have to say, you know, go into this folder and pull out this asset. In addition to that, we're going to have these sort of binary packages that we ship with a release build. That's basically going to take all the assets and put them into kind of a zip file, not really, but it's basically going to, you know, bake them all into one giant binary file. And so the virtual file system is going to know how to deal with both of those type of things, whether it's dealing with binary packages or whether it's dealing with the on-disk version of that. And it helps us handle hot reloading and things like that. It doesn't yet, but it's going to. And it's going to abstract all of that away from the engine. So the rest of the engine doesn't have to worry about it. And that's why we say virtual file system, because then we can say to the file system, hey, I want the asset that's named this. It's in this package, but as far as where that exists outside of that, I don't know, right? So when we request something like this, right? This is a good example of how this is going to work when we put it all together. This shader file, for example, is saying, hey, I have a source asset that's called static mesh underscore vert, right? And it's in a PBR folder. Now that PBR folder exists within a runtime package, right? So that runtime package could either be that binary blob that sits on disk, or it could be a direct route to a path. And then if we look at what we call an asset manifest, this is what actually makes that translation to, hey, this material called Arch actually exists here on path on disk. And then some of these even have a source path, right? So if we wanted to talk about the Vulkan mesh, right? We've got a mesh called Vulkan. It's a static mesh. Its kohi sort of binary version, native version of that exists here. And the source path that was used to create that, or what it was imported from, exists here. So we have kind of both of those things. And so the way that this works is we have the packages, and then we have the VFS that sits on top of the packages and interacts with both packages as well as the actual file system underneath. And the engine doesn't have to worry about any of that stuff. It just completely abstracts all that stuff away. And so by having that in place, it just makes things a lot more convenient from within the engine in terms of accessing things. So I hope that clarifies a little bit. Much clearer now. Thanks for explaining. Yeah, no problem. Never be afraid to ask, by the way. The Hat Man is a figure many people who abuse Benadryl claim to have seen. Don't abuse Benadryl. Yeah, I definitely don't. I only take it when I have a severe attack. And I take a lot of it to sort of ward that off. But yeah, it's one of those things where like you're not supposed to. I think you're not supposed to take more than like 2 a day, which is what I limit myself. I just take Benadryl and then go pass out basically, and then I wake up and I'm coherent and I can at least function. Haven't heard of the Hat Man thing though. That's interesting. I've never taken that much Benadryl. All right. Okay, so where were we? All right, so K-asset shader. Obviously, we have our base asset information here. So we basically need to break down all of these different properties into either structs or properties within this structure. So we do have this stage information, which previously was just arrays that sort of had to line up with each other. That's kind of rubbish. So we're going to go with a typedef struct, and we're going to say K-asset shader, and then we'll say stage. I guess that works. Shader stage. And I think what we're going to do here is we do have a string representation of what the type is, but we're going to go ahead and convert that to an enumeration, which we already have a few of those, right? They're in our core render types. So we have shader, stage, vertex, compute, fragment, blah, blah, blah. So we're going to do shader, what is it? Shader stage? Yeah. So we'll do that. And then we're going to say a constant string, and we're going to say source asset. And that's just going to be the name of the source asset, right? Like, I suppose we could say source asset name. And then we're going to do const string package name. And that'll be it for those, right? And then down here, we'll do U32 stage count, and then shader stage array. stages. Oops, stages. There we go. So that's those. We then have B8 depth test, B8 depth right. I know we also have a stencil test, and whoops, that should be B8. And I think it was stencil right, I want to say. Yeah, stencil right. So that doesn't appear in this one, but it is a property that we have. So we have another one, stencil right. And then we have the max instances, which is how many instances of the material instances, you can think of that, how many of those we can have. So let's use, I think a U16 is enough to hold that. So we'll say max instances. Let's see. And then we have attributes and uniforms, and I think that's it. So attributes and uniforms, we probably are going to keep those structured the old way. We'll just read these out this way, I think. Because I don't really want to set up 3 arrays. It's kind of annoying. It'd be better to just be able to loop through them all in code. So what we can do is up here, we will do another type def struct, and we're going to do kasset shader attribute. Kasset shader attribute. And the first thing that we're going to want is the name of the attribute. And then we're going to want its type, which is going to be shader attribute type. And that's just going to be type, right? So we have that. Obviously, that means we'll have U32 attribute count and kasset shader type. Shader attribute type. There we go. And then it'll be attributes. So we have an array of that. And then we'll have uniforms. So type def struct kasset shader uniform. There we go. Again, we have a name, and then shader uniform type. Oh, and we forgot scope for each one of these. Or no, attributes don't need it, but this does. So shader scope. And then, of course, down here, we'll have U32 uniform count, and then asset shader uniforms. All right, and that is our structure for loading a shader asset. So again, that's separate from the shader resource, which we're going to talk about later. We're going to rework that as well. And we're going to sort of separate all this stuff out so that we don't have the weird overlap situation that we do now. All right, so let me see. Tammin, good to see you. I'm doing pretty good. How about you? You have to cook some dinner. You'll be back later for the rest of the stream. No worries. I still have a typo on in text chord. Ooh, you're right. That would have been gross. Thank you for that. Okay. So basically, as a reminder what this is essentially our metadata that tells the engine how to construct the graphics pipeline for this, right? So we have that, and I believe with that, we are actually ready to start serialization. So let's go back to our shader serializer. Okay, at this level, that's fine. So I think we can just drop right into the C file and start working. Okay. We missed one here. That should be shader. Does this say height map anywhere else? Aside from that, which we're going to blow away. Right, these are regular string implementations of, or instances of this. Yeah, here we go. So we're going to get rid of that one, so I'm not worried about that. And then that's just clean up. Okay. All right, so we can start at the top. We're going to start with serializing, and then we're going to work backwards and do the deserialization. All right, so the very first thing that we're going to have in here is the version. So we want that. We want to request that first and foremost. So that will be fine as is. Let's see. I suppose we could let's take some of these properties and put them up here, right? The order of these doesn't actually matter, but it might make the file a little bit easier to read. And this is basically the order that we're going to request them. So it doesn't actually matter where it physically appears in the file, but you know, just for the sake of us understanding where this stuff is actually requested. Okay, so we're serializing, so we always want to serialize the latest version of this, right? So we want to define that as a constant up here, and we're going to say define. We're going to say shader asset version, and in this case it's going to be 1. So instead of using this, this is really just used during loading. We're going to say shader asset version here. So we're always going to write out 1. Anytime we increment this, we'll just increment this version up here, and then adjust the serialization code to handle that accordingly. Okay, so let's get rid of this because we don't actually have any strings we need to process here. So let's just get rid of that. And then instead of chunk size, the first thing that we're going to pull up is this is an int, so we'll do max instances. Right, so max instances. And then max instances is actually not required. So you can have a shader that doesn't have instances at all. So this field is not required. So actually, you know what though, if we don't find it though, if we don't find it, it's going to default to 0. That's fine actually. So we'll go ahead and nuke all of that, and then it'll just default to 0 if it's not found. All right, so the next thing that we have is a few booleans, which I suppose we should always write those out, right? So I guess we'll do depth test, and then we'll do case and object value add bool. It's going to be to the tree root. The name is going to be depth test, and the value is going to be asset, or it's going to be typed asset rather, depth test. And again, these fields aren't necessarily required, so when we go to deserialize them later on, they'll be optional. So we're not gonna fail on that. And I don't see any reason why it would fail to actually add it, so I'm just not going to bother checking that here. So we've got depth test. Let's go ahead and we'll do stencil test next. And then we'll do depth right. Right. Okay, and we'll just grab this and do stencil right. Okay, and that's the output for those. So pretty straightforward stuff. Side question, still figuring out best practices, but does each object you render have its own vertex buffer and index buffer, or all objects stored in one vertex buffer? So in our case, we have a sort of a global index and vertex buffer that we use. So we actually use that for a variety of things, not just things we draw in the world, but we also use those for UI or anything that's drawn that way. That is a bit of a problem right now. There is a bit of an issue we need to resolve with that, where we really need to have two sets of those. One for static data that is not updated very often, and then another one for what we'd call dynamic data that updates every frame. And the reason for that is because those need to be handled differently. And right now we're kind of doing all of those in one, which isn't necessarily the right solution either. So we do need to split that out. That is something we need to do. It's not going to be like super high effort to handle that. It's just something we need to do. But to answer your question, everything right now is pointing to a single buffer. And that's ideally the way that you should have it. You don't want to be switching buffers all the time. That would be bad. Just started working on a simple 2D tile sheet game engine with SDL to teach myself C. Perfect. That's the kind of stuff you want to do. That's awesome. Thank you for all the videos and streams. They help. Awesome. I'm glad to hear that they help. I'm super glad to be of help there. So I appreciate the feedback. Thank you. All right. Okay, so we have all of these things written out. Now we need to create a stages array. And put in our stages. So the first thing that we need to make sure is we need to look at the typed asset shader. What was it? Stage count, right? We need to say U32 stage count. And then it's actually invalid to have one of these without any stage information, right? Theoretically, we would always need, let me think. We always need stages. I believe we always need attributes. I can't think, well, no, actually, I guess you don't. Theoretically, you could have a shader that has no attributes and just writes something to the screen based on the data that's hard-coded into the shader. So technically, you don't have to have these. And you don't have to have uniforms, right? So these are all optional, but you have to have stages. You've got to have at least one. So actually, I think before we actually do any of this stuff, we should probably look at the shader first and say, hey, is this shader actually something that we should be serializing in the first place? So what we can do is right here, right after we cast it, validate that there are actual stages because these are required. So we'll say if not typed asset stage count, and we'll say asset shader serializer requires at least one stage to serialize. Otherwise, it's an invalid shader, you dingus. Right? And we'd return false. Or not false, 0 in that case, right? Because we wouldn't be returning a string. Okay, so now that we have that validation done, now I can actually come in here and create the array. So we'll do case-in array, and we'll call this stages array, and we'll say that equals case-in array create. And then what we can do is for u32, I equals 0, I is less than, typed asset stage count plus I. And we can come in here and create, let's see, case-in objects. Object. And we'll say stage object equals object create. And then to that, we can add our properties, like our type and things like that. So do we have a string representation of our stages? I don't think that we do. So we'll have to look at that. Is it good practice to put user-defined functions on top of main for C-based languages, or does it not really matter? It doesn't really matter. It's preference, right? You're talking about, like, should your main function be all the way at the bottom of the file? Who cares? You know? What I would say with that is the only thing that I tend to lean towards more is I do personally find it a little bit better if you forward declare your functions at the top of the file above main, but then actually define them below main so that the first thing you see when you open that file is main and you can see what gets called. And that helps you kind of step in mentally to the program as to what it's doing. But is that a requirement? Absolutely not. Yeah. So it's one of those things that's preference, right? I'm not going to look at a project and go, that's a bad project because they didn't put their files or, you know, their stuff in a certain order. Yeah. That's what you've been doing. Yeah. So, I mean, that's what I do. That's what I prefer. But again, it's a preference. So I'm not going to poop on it if it's, you know, somebody's got something in a different order. Doesn't tend to be very productive. You know what I mean? Bought a Raspberry Pi 5. Got some issues with not enough power on my 1 terabyte SSD NVMe. That's not terribly surprising. Very curious to test Kohi on the Raspberry. It should support Vulkan. Oh, I would be... It is not optimized in a lot of ways right now, so I'd be interested to see what results you get with that. I would be very interested to hear how far you get with that. Okay, that's one of the things we're going to have to do somewhat soon as an optimization pass, actually. All right, so let's all right, we need to see if we have string representations of these types. Okay, so if we do what did we say? Core render types. We have shader stages here, texture repeat. Didn't we define most of this in our, was it render utils? Uniform type is sampler. That's the only thing that's in there. That's kind of dumb. We might nuke that file. Render type utils is the one I'm looking for. Let's see. We have uniform types. We have some of this stuff in here. This is probably where we'd put it. Material, because we're kind of writing these as we need, right? We do not have that in here, though. We do not have anything for... We don't have attribute types in here either. Okay. So we need uniform types and we need shader stages. So I guess let's do this. shader attribute type to string. Shader attribute type. We can copy pasta this and just change it. Turns the string representation of the given shader attribute type. So we've got that one. We need the opposite of that. So shader attribute type string to shader attribute type. Grab this, put that here. Attribute type. All right, so that's that. And then we need, what was the other thing? Stage. So we'll do KPI const character array. At the end, you dingus. There we go. Shader stage to string. Shader stage. Oh, we need shader scope too. Stage. And let's grab this. So we just got to write these things real quick. That way we don't have to worry about it. Stage. And that's just, whoops, that. And then we have, I'm just going to copy it this time. Instead of shader stage, we have shader scope. Scope. There we go. And we just need the opposite of that. So I guess we'll just do shader stage. 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 And then scope. Okay, so now we can take these guys. And we'll go render type utils right below this guy. So okay. Oh, why has it done that? Okay. So, these ones, let's actually do the other half of this first, because it'll make this go a little bit speedier. All right, so right here. Okay, so here we can just do a simple switch. And we can do type. And then autofill. And then we can do the same thing here. So switch, type, oops. Oh, that should be stage, not type. Okay, and then one last one here, which would be, oh, I named that stage, that should be scope. Switch, scope, scope. Wow. Typing is apparently an issue for me tonight. Okay. Don't understand why people prefer Twitch. Get a pop-up ad on top of the video on Twitch, and YouTube I get no BS. What am I missing? I mean, Twitch is better for interactivity, right? Plus, I keep forgetting to manually trigger ads on YouTube because it's a manual process. It's not like automatic like it is on the Twitch side. So, yeah, whenever ads trigger on the Twitch side, I have to like manually do it on the YouTube side. But yeah, I mean, it's better for interactivity overall. Kevlar, how's it going? Good to see you. Trash Can, good to see you as well. Nick Deli, first time chat as well. Hello. Oh, yeah, I already answered that one. Okay. All right. I scrolled back too far. LEB, good to see you. How's it going? They're missing ad block. Yeah, fair enough. All right. Okay, so let's fill this one out, and then essentially what we'll do is we'll copy this over to the other side, and we'll have like all the data we need. We just have to sort of reformat it. So if we have a attribute of float32, we're going to, are we returning a copy of the string? I forget. No. Okay. So in this case, we'll return F32. In this case, return vec2. And I'm just going to copy pasta this. And I'm going to do vec3, vec4, copy pasta this to mat4. And then here, I'll do return I8. And then this is U8. And then paste again. This will be I16. And then U16. And then I32, U32. All right. So that's nice and simple for that. So that's attribute type. I'm surprised we didn't actually do that when we did uniform type, but it is what it is. Okay, so so this one we're always going to output vertex. For this one, we're always going to return geometry, return fragment, and return compute. Okay, I guess we don't need this extraneous break down here in either case. And then when we read these things in, we're actually going to accept abbreviations of these as well, but we'll handle that in a minute. So shader scope, we're always going to output global. Then instance. Oops. And then local. All right, so the output's always going to be fairly consistent with these guys. Extraneous break there. Okay. However, the sort of opposite side of these is not going to be quite as straightforward. So let's just find that real quick. Here we go. All right, so here's the string to attribute type. So essentially we don't have a switch, right? So what we're going to do is we're basically going to do a bunch of ifs, right? Because you can't, unfortunately, do a switch with a string. So we'll do string equal I. We want case insensitive compare here, right? So we're going to do, first off, for this one, we're going to do F32. And then we're going to do string. But we're also going to accept strings equal I. We're also going to accept float here. Right? So if either of those, then we are going to return that, right? Right, so that's basically the way we're going to do it. In fact, I'm going to make my life a little easier here and just do this. Actually, I don't need that one. And then copy this. For this next type, I think we're just going to accept vec2 for this. We're not going to accept any variants for that one. Right, it just needs to be vec2. So we're going to take that one, use that same thing for vec3 and vec4, and 4, and then also mat4. And then actually most of the rest of these are going to be kind of the same deal. So let me just, I'm actually just going to paste this over and over, and I'll just change each individual string. So this is U8, so we're just going to accept only U8 for that one. This one is going to be, oops, I missed one. So it should be I8 here. Then this one is U16. And then this is, whoops, U16 is this one. This one should be I16. And then this is going to be I32 and U32. And then we are going to accept an alternate one for I32. Strings equal I. We're going to say also if they say int, then we're going to accept that as well. There. Okay, so we should probably actually make all of these like else ifs, right? Right, and then else, we'll throw an error. Unrecognized attribute type, and we'll spell out the string that they provided us, right? Maybe we should assert on that instead of throwing an error. I think we're going to assert on that. Let's do that instead. And we're going to say, oh wait, you know what? If I do that though, I can't have a formatted string there. Nah, I'm just going to throw an error and return in 32. So we'll say defaulting to int32, or i32, I guess. Okay. So that's that one. We just have a couple of alternates that we'll accept as well. But that should mostly get us there. Doing good, writing my first NeoVim plugin, and it's well. Yeah, I get that. Been following you on YouTube for a while. Usually miss the streams, and oh, you know what? I'm going to read that after ads because we have an ad break. Let's see. So I do see your messages over on YouTube. We are taking an ad break right now because ads are running on Twitch. I'm going to trigger them here on YouTube as well. And then when we come back, I will answer those. Did it do it? There it goes. Okay. Give me a chance to hydrate as well. So we've got about 45 seconds left on ads. And so, Shorty, I do see your questions over there on the YouTube side. I'll get to those in just a second, all right? Thank you for the stretch redeem. Appreciate that. Incidentally, well, you know what? I'll say it after ads, actually. Okay, ads are done. So I like to just pause the stream whenever ads come up, by the way, which is every 30 minutes for up to 90 seconds, depending on region or locale on Twitch. So we try to sync the YouTube side to match that. In terms of redeems over on the Twitch side, by the way, there is a redeem, if you look through those, for 100,000 points for credit, right? So if you're in this for the long haul, save your points, because that gets your name in the credits. So, yeah, that's a thing. All right. Anyway, so to answer your question, Shorty, can you show the game? What computer language is this? This is C. And then I don't have a like exclamation point donate, but I do have like a Patreon and a Kofi or Ko-Fi. Those links are in the I think they're actually listed on my YouTube channel as well, as well as the description. I think they're in there. But yeah, I can show sort of the test environment that we have working at the moment. There's a few things to show off, I suppose. This is kind of what we're working with so far. So all of this stuff, by the way, was written completely from scratch. We're not really using any libraries except to import some assets. But this is what we're looking at. So we have we've got basic PBR lighting with cascaded shadow maps in here. We recently added water. We have static meshes. We have transparency working. We have the ability to like change different modes, so we can look at lighting only if we wanted to. We could look at normals. We could look at how the cascading shadow maps look, and so forth. Or we could even look at a wireframe view if we want. So we have all those different things. We have this Sponza sort of test thing that you've probably seen a billion times in different videos and stuff. So we have this guy in here as well. But most of the work that we've done is actually, believe it or not in the renderer. It's actually other aspects of the engine. So, there is a lot of rendering work, obviously, but yeah, this is basically what we have so far. We do have the ability to like click objects and move them around or scale them in the scene, right? So in this case, I can move it, or I can rotate it, like so. Right? Or I can scale it to some ridiculousness, whatever. So we do have all of that capability, right? But yeah, what we're working on right now is a redo of the asset system. So I hope that makes sense. Okay. Now, to answer your question, Nick, actually, I don't think it's a question. I think it's a statement. Been following you on YouTube for a while, but usually miss the streams. And since I've been learning C++, I figured this is a great stream to have on the side when I can catch streams. Awesome. I appreciate that. And yeah, welcome. CTS Official, thank you for the follow. I appreciate that. Welcome. Okay, so we need strings to shader stage and then string to shader scope. So those were up here. We're basically, I'm just going to copy both of these. And we're basically just need to do the opposite of this operation, right? So let me just paste this one here. And I'm going to remove this and grab this and move it here. And then we're basically just going to switch this up. Pardon the pun. So let's do if string equal I. And we're going to say vertex. So if the string passed in is vertex, or it's just vert, right? Which is an accepted abbreviation. If it's either one of those things, then we're going to accept that and identify that as the vertex stage, right? So let me just go ahead and do this and return. We actually don't need this. And then we actually do need this, right? So we'll get that in here as well. And then, oops, I don't need this one. And then for each one of these guys, we're just going to slam in one of these. Okay, so for geometry, it's either geometry or geom, right? For fragments, it's going to be frag, or compute, it's just going to be comp, right? So compute, right, and fragment. All right, now it's bleating that we don't have like an else case here. So these actually should all be, these should be else ifs, right? And then we'll do else here. And we'll do k error, unknown, shader stage, and we'll spit out the string, and we'll say string here. And then we'll return, I guess, vertex. Right? So I guess we'll say defaulting to vertex. All right, so we have that fallback there. And then this one, I'm not going to bother with all the copy pasta stuff because it's only a few cases that we have to worry about here. So strings equal I. This is either going to be global. Actually, we're just going to accept global for this, I think. Let's keep this one simple. Right, so we're just going to accept global. And then return that. Let's get rid of this. Okay, and then we'll do, actually I am going to copy this, I lied. Back. Let's do, actually, oops, we want that one line up. Okay. So we want instance here and local here. Return. I swear I type return wrong more than any other word in English. I'm always always typing it backwards. All right, else. Right, and then else here. And I'm actually just going to do a copy pasta of this, but change it to undo shader scope global scope defaulting to global. Okay, so that is that. That's our utility methods. Nice and simple, but this keeps us from having to put that in our serializer and potentially other places as well. I think my message on YouTube got missed, so hi again. Oh, it did it? You're right, it did. It got buried between other ones. I'm sorry about that. Let's see. I just set up OpenVPN on my server so I can watch you on YouTube, but I still do on Twitch. Awesome. I appreciate that. How are you doing, by the way? Yeah, I don't, sometimes my eyes just like miss messages, especially like, well, here, I'll show you. I'll show you what happened in this case. Where did my image go? All right. Let's expand this out a little bit. So, basically what happened here is I think it got lost because of the color, the username, right? Like it's between, you got all this colorful stuff around here and then it like showed up gray. And my brain just like filtered it out for some reason. 30 active chat windows moment. Yeah, there's that too. Doing well, making a launcher for your Minecraft mod. Nice. Part-time dude, let's go. How's it going? Okay, so we've written these, which we needed back for our serializer. So that was here, I think. Yes, here. Okay, so the whole point of all of that was to be able to get this stuff to and from text easily. So let's see, we did stage count validation. Here's all of our properties. I think we were to here, yes. So this is stages. So for each stage, we need to add the type property. So what we'll do is we'll say KSON object add string. The object itself this time is going to be the stage object. The name is going to be type, right? That's the name of the variable that we're putting here. And then the value is going to be what was it? We need the string version of that. So we need the shader stage to string. And the stage that we're going to provide it is going to be the typed asset. Oh, you know what? Let's get a convenience pointer for this, actually. Because that's going to have stages, right? Which is kasset shader stage, right? So let's do this. Let's do kasset shader stage. And we'll say stage equals the address of typed asset stages sub I. And then we can just say stage over here. Stage. And then we want stage. Oops. There we go. Okay. So if we move this over a little bit. So here's how we're basically going to add our properties to build this out, right? So we have our type here. And then we have our source asset and package name, which are a little more straightforward. So the next one's going to be source assets. And we don't actually need a function call at all in this case. It's just going to be stage, source asset name, right? So we have, oh, that should probably be source asset. Should we put name in here? I feel like we should. I think that makes, keep it consistent between both sides, right? So let's do that. Right, and we can actually copy pasta that line, and we can do package name, and then once we've gone ahead and built out the object, then we can go casein array, add object, and the array this time is going to be the stages array, and the object is going to be stage object, right? And now this is added to this casein array. Once we're done processing that, we can then add that array to the root object. So we can say casein object add array, and the object this time is going to be tree root. The name is going to be stages. And then the array value is going to be stages array. And there we go. So we've added these properties and this. And then all we need to do at this point is just add attributes and uniforms. Attributes will be a little bit more straightforward. And then uniforms will require a little bit more finagling to figure that out. But we'll get it. All right. Let's see. Nowadays, I think very few people on Earth know the C language, and you're one of them. It's like a superpower. Oh, there's lots of people that know C, but it's not as common as it used to be. I agree with that. Lots of people go the C++ direction, which I suppose is fine, but yeah, C goes everywhere, right? C is everywhere. Not necessarily so for C++, although C++ is right behind it in terms of that, but C is on every platform. Okay, so let's get rid of this stuff because we don't need any of this stuff. This is just rubbish. Okay. So, whoops, I think I did delete something there that I need though. This is rubbish. I do need this though. Output to string. All right, so we're basically going to repeat this process, but for our attributes. So what I'm going to do is I'm going to scope this off. And the reason I'm doing that is because I can take a copy of this and paste it down here. Oops. And just add a little bit here. And then I can rename this and not have to worry about it leaking up into this other section as far as renaming. So this is going to be attributes. And then I can rename this attributes array. We're going to look at attributes count. We're going to rename this to attribute object. We're going to change this to attributes, this to attributes. Oops. And then we're going to rename this guy to attribute. And we'll change this string to attributes. And we're like 3/4 of the way there already. So the only thing we have to worry about for attributes is type and a name. So we only need 2 of these. So type is just going to be attribute type. And then we don't even need, wait a minute, what is attribute type? I think is shader attribute. Yeah, so we need a shader attribute to string. Did I not? Didn't I create that? Could have swore I did. Oh, attribute type to string. Okay. Attribute type to string. Sure. Okay. And then name is just going to be attribute name. And that's all there is to adding attributes. So now this is done. Now, uniforms is going to be a little bit different. So we're going to have a little bit of a logic here, but it's not really going to be a huge departure from attributes. So we're going to take this and again use it as a template for our next section. Okay, so what we're going to do is first off we'll put, we need 3 arrays, right? 1 for global, 1 for instance, and 1 for local. And that's only if the count of those things actually is, So we could loop through each one of those, look at their type, and then say, just keep a count of each, right? Maybe that's the way to do it. And then we know how much to allocate ahead of time. Yeah, let's do that. So this is going to be uniforms. Get scope counts. So we'll have a U32 global count, and that'll start off with 0. Again, we'll have a local count, and then a instance count. Let's just reverse those, keep those in the same order. Right, and then what we'll do is we're going to loop through this collection twice. So I'm actually just going to copy this. Right, and instead of attribute count, we're going to do uniform count. And we're going to do a switch on typed asset uniforms sub I type. Whoops. Just type. Type. There we go. All right, so case uniform. Oh wait, not type, scope. Sorry. I was like, that's going to be huge. Scope. There we go. Shader scope. And then we want, let's do global first. Right? And then case shader scope instance. Oops, dang it. Shader scope instance. And then, oops. Case shader scope local. All right, so for this one, we're going to say global count plus plus break, and then we'll say instance count plus plus break, and then we'll say local count plus plus break. All right, and then we're going to, let's rename this to, we actually need to create 3 of these. So I'm going to rename this to globals array. Or I guess just global array. That's fine. And then we'll have one for local and one for instance. Okay. In creating these doesn't like stand, well, actually, does it stand up any resources? Let me see that. No, it doesn't. Okay. All right. So calling these creates is not a big deal. If we don't wind up having anything of that type, we'll just not include it. So the way that this is going to work is we'll do uniform count. Right. Oh, you know what? I could actually keep these counts. No, that's fine. All right. So we have our uniform count. So we're going to loop through our uniforms again. And I suppose we could actually just... Actually, do I even have a need to actually do these counts? Come to think of it. I am going to have to do that when deserializing. I don't actually think I need that count, come to think of it. I don't need this, actually. Come to think of it. Goodbye. All right, so what we're going to do is we're going to rename, and we're going to say uniform object. So we're going to create that. We'll go ahead and say uniform. This is going to be uniforms. And we're going to rename this as well to just uniform. And what we'll do is we'll create the object as we normally would. And the only difference is going to be which array we actually add it to. So we'll create the type, which is going to be the uniform type. So uniform type and the name. Yep, okay. So none of that really changes. The only bit that changes is this. So I guess we could set up a switch for this. I think if statement's easier in this case. So we'll do if uniform scope equals uniform scope, not uniform scope, shader scope, global, then we do this as normal. Else if uniform scope equals shader scope instance. Dang it. Chose the wrong one again. Right, or else if uniform scope equals shader scope local. Do this. Else unknown shader scope skipping. We'll just continue. Actually, we don't even need that because we don't have any logic after that within the loop. All right, so we can copy this guy and pasta it here and here. And the only thing is for instance, we want the instance array, and for this, we want the local array. And then once we're done, we have, let's see, we're going to call this global. Or actually, we need to say uniforms. We do need the counts for one thing. Because if we have one of these that doesn't actually have any uniforms, we don't need to add any of this. which actually the same thing applies for attributes. So that's actually technically a bug. So let's do this first here. We'll say attrib. Wait a minute. We already know the count for this. So we can actually say if. Let's wrap this whole thing. Actually, you know what? Let's use this upper scope that we have here. This actually makes the most sense. We'll say if. Thank you for the follow, by the way. We'll say if typed asset attribute count is greater than 0. Then we'll do this. By the same token, we'll check here. We'll say if typed asset uniform count is greater than 0. Then we'll do all of this. However, conditionally speaking, we also need to know the numbers of these individual arrays, because there's no point in saying, you know, global and then have it be empty. So I guess we will do a U32 global count equals 0 instance and local count, right? And so we can actually just global count plus plus instance counts plus plus and local count plus plus, right? So before adding each one of these arrays, we just do this. This needs to be add object. So that's the outer sort of uniform object, and we need to do a create on that up here. So casein object uniforms object equals casein object creates, right? And so this will be uniforms object. Okay, so that creates this outer guy here. And then we'll go through each of these counts to determine if we need to add this one, or this one. And then we'll add them accordingly. So if global count, then we can do casein object add array, or value add array rather. The object in this case is going to be uniforms object. The name is going to be global, and the array that we're going to add is obviously the global array. And this object incidentally needs to be added at the bottom because we're modifying it and then adding it. We need the address of this guy. Okay, so that's global. Then we have instance count, instance array, and finally, oops, local count, local and local array, right? Okay, so we only add these things if we actually have, my power is like flickering like crazy all of a sudden. I don't know what's going on. Hopefully the stream doesn't drop. All right, so we create the uniforms object, which is this outer object. We create the arrays, we add things to those, we check the counts. If those counts are existent, we add those arrays to the uniforms object. We add the uniforms object to the tree root, and at that point, we are done parsing this file. So that is it. Then we output the whole thing to string, clean up the parse tree, and return the string. So at that point, our serialization is done. Now all we have to do is the opposite side of that equation. H. Mendoza, how are you doing? Hello. Singy, hello. How's it going? All right. So I think the way that we're going to tackle this is we're going to keep the top part of this. We're going to keep version because that's relevant. But we're going to get rid of everything else up until when we do the tree cleanup. All right. So this just returns true or false on success. We do some cleanup here on not success. I don't think we're really going to have a lot to clean up there, though, so I'm not really too worried about that. In fact, I'm actually going to kill this section for now. Is this needed? All right, and we'll come back to that. Okay, so the idea here is now we have we're deserializing, so we're reading this file. We're not writing this file at this point. We are taking this entire thing in as a string, sending it over to our KSON parser, and creating a tree from it. And then instead of adding objects and things to arrays and properties to arrays and objects and all that stuff, we're going to basically be parsing or pulling that information out. So to do that, we're basically going to be using these gets as we are with version here. We're not going to do any version validation because we're just on version 1. But, you guys have seen how we do that with other formats. So what I'm going to do is I'm actually going to grab all of this stuff because we can use the structure of this and basically just reverse everything to give us what we want. So let's paste this in and we'll start here. So max instances. This is not a required field. So we'll say get int, right? Max instances, and then we'll take the address of typed max instances, typed asset max instances. Why is this bleating? Oh, right, because max instances is a U16. So basically our KSON file format only deals with 64-bit integers signed, and so we have to convert that. So we'll say I64 max instances, right? And so what we'll do is we'll take that and do max instances, and then we'll say typed asset max instances equals U16 max instances, right? And we'll just handle it that way. And so it'll either be 0 or whatever was provided to us from this if it exists. So if it doesn't exist, not a big deal. It's not required, and we don't need to worry about it. With that said, so depth test, write, stencil test, stencil write, those are all optional as well, and they all default to false. So it's kind of going to be the same thing. We're going to have B8 depth test equals false, and then we'll do get boolean, and this is going to be just the address of depth test, right? And then actually we don't even have to do this, come to think of it. We can actually do let me undo some of this. We can keep that. We just need the address of this, actually. We don't have to do any sort of conversion on that. So let's actually just get bool Okay. So all we need to do is just pass the address of these. And again, since all these properties are optional, we're not going to check to see if it found it or not. We'll just use the default, right? I suppose what we could do, if these don't get updated, right, they're not going to necessarily be defaulted to false. So what we'll do is we'll do depth test equals false, right? And then I'm just going to pasta this in here a few times and do right. Let me actually just do that, and then stencil test stencil right. So we'll default those things to false, and then if we find them, they might be flipped to true or false. Doesn't matter. Okay. So the next thing we need to do is parse stages, and stages is required. So if we don't find that, then we're up the creek without a paddle, right? So the first thing that we need to do is, we'll create a KSON array here, and we'll call this stages array, right? And the reason we're doing it at this scope is because we want to say if KSON object get, I think we have to get this as an object. I don't think, it's a little bit confusing. I probably ought to add like an alias function in here, but objects and arrays are mostly the same thing in KSON. They're interchangeable in a lot of ways. It's mostly how their properties get treated. So we can get it as an object, and if it's created under the hood as an array, it'll still work as an array. So we want to get this from the address of tree root, and then the name is stages, and the value we want to write this out to is stages array. We need the address of that. Okay. So if we do find that, then we go ahead and process it. Yeah, otherwise, if we don't find it, that's an error. Stages are required for shader configurations. Make sure at least one exists. Okay. And in this case, we're going to return false, right? Serialization at this point is considered failed. Now, before we can actually loop this, we actually have to get the array count. So we have to come in here and say KSON object, or KSON array rather, KSON array element count get, right? So the array that we're going to do is address of stages array, and the count is going to be U32 stage. Actually, we could just do typed array, or address of typed array, typed asset rather, stage. No, we can't actually. We have to do a I64 first. I64 stage count equals 0, and then stage count. And if for some reason we're not able to get this, that's also an error. So if we don't get this, or stage count is equal to 0, then we're also up the creek without a paddle, right? So we need another, I think, stage counts. Oh, does this want a, that does want a U32. Maybe I can just, that is a U32. Okay, I can use that in that case. All right, so typed assets stage count. And that one is extraneous. Okay. All right, so if either one of those criteria are met, then we have to put this again, right? That's a failure scenario. We require at least one. Thank you for the follow. I appreciate that. Greetings from Egypt. Awesome. How are you doing? That's a long way away. What time is it over there? It's got to be like early in the morning over there, I would think. What's that, about probably 6 hours ahead of Eastern Standard Time or Eastern Daylight Time in the US? It's going well. 5 a.m. just got up. Okay, yeah, I figured it was pretty early in there. So it's a bit more than that then. It's like 8 hours. Yeah. Well, welcome. Glad to have you here. Okay, so we have the element count. Now we can actually go through that. We have our stage count. So what we need to do here is we actually need to set up this typed asset stages. So typed asset stages equals kallocate. We're going to do a size of, and this is going to be a k-asset shader stage times typed asset stage count. And we're going to memory tag array that guy. All right, so we'll go ahead and set that up. And then we loop through our array the same kind of way. Instead of adding the strings, though, we are going to be getting them. Xenonoid, welcome. First time chat as well, welcome. I appreciate the follow. What are you doing? Okay, so what I'm working on right now is a serializer / deserializer, and I'm specifically working on the deserialization of this file. So we've already written the serialization of it. Now I'm working on the deserialization of it. What this is it's a shader configuration file. And so this basically instructs the engine on how to construct a shader. And we're changing up the format and creating like a new asset loading system across the board for all of our different asset types to make things a little bit more modular, more flexible, and able to be Javafied so we can multi-thread all this stuff. And so that's what we're doing now. We're just sort of overhauling that whole system. Because there was sort of a lot of technical debt that was built up there. A lot of the assets were kind of loaded in very ad hoc ways that kind of fit the tutorial format at the very beginning of the series, but we never kind of went back and standardized it, and that's what we're doing. Do I have a UI for the engine already? Somewhat. I have some basic UI controls. We're rolling everything from scratch, so I don't have everything yet. Mostly what we have at the moment is we have two types of text rendering, so bitmap fonts and system fonts, which can handle any sort of UTF-8. And here, I'll show you real quick. I'll just run it. Right, so our basic UI is, we have, this is bitmap text, this is what we call system text, which supports UTF characters. So these are Japanese characters, and then that's a Korean character there. And then we have basic buttons here that are interactable. And then, we've got a couple things like a drop-down box, like a Quake style sort of dev console here. And then, our actual scene kind of looks like that right now. So we've got some basic stuff going on. We're just changing the way that our assets work. Do I have SDF? No, not yet. Nope. So the way that these fonts are rendered is we create a a bitmap font is pretty obvious, right? That's pre-rendered. But the system font basically has a dynamic atlas that's created on the fly based on what characters we need rendered for that particular font and size. And then I guess once we get to SDF, the size thing won't matter as much. We generate a different atlas per size right now just to get it to look good. But once we get SDF, I suppose we won't need that. But yeah, these atlases for this for these types of system fonts actually use the true type fonts and generate an asset or generate a atlas on the fly. So yeah, we're not there yet in terms of fonts. There's still some more that I want to add to it. Obviously, SDF will help me get there in terms of being able to like underline, outline, that kind of stuff. But yeah, not yet. All right. So this is not adding string. In this case, we're just going to change this to get string. Also, we need to, instead of this case and object create, we actually need to get this from the array. So we need case and array element. Not element type at. I think we want get object. So the array is going to be the address of stages array. The index is going to be I, and the object that we're going to save to is the address of stage object. Right? So that's that. So we're just going to initialize this with all zeros, right? And then we'll load it here. This is in our actual array that we're writing to. Now we can get a string from the stage objects. In this case, we are parsing, let's see, we're still on stages, so we need type. So here, we were doing shader stage to string. Now we want string to shader stage. And I guess we're going to have to do that in 2 steps, I think. Yeah, we are. Okay. So let's just do a temp string here. We'll pass that here, so the address of temp. Right, that'll allocate a new string. Then here we can do stage type. Wait. Stage package name source asset. Did I just call that stage by accident? That doesn't seem right. That should be called type. Okay, let's do a string to shader stage, and then we'll do temp here, and then we'll do string free temp. And we'll basically just do that for each one, right? So we have to extract it as a string, convert it to an enumeration, and then go from there. This needs to be renamed to type. And of course, that rename didn't work properly. Why not? What is type here? It did work. Why is it bleating and saying that it didn't then? IntelliSense is just freaking out on me, I guess. All right. So we basically need these other ones we can extract straight up strings. So we can do get string, case and object, get string. All right, so, that's going to be the same. The only difference is we're going to take the address of these guys. All right, and that's it for parsing stages. So that's that. We don't need this, by the way. We don't need that because we're not building the array. We're reading from it. So we're basically going to follow this pattern now for attributes and then for uniforms. Which uniforms is going to be a little bit weird, but we'll make it work. Okay. Stages are required. Okay, so if we don't find that, we error out, return false. That's good. Okay. So attributes and uniforms are both optional. So if we don't find them in this case, we're just going to move on. So I guess before we even, well, this check needs to be changed with basically object property value gets object. So we're going to get this from tree.root. The name we're going to get is, we're going to do attributes first. And then we're going to output that to attributes array, which is going to be here, which is going to be initialized to 0. So we want the address of attributes array. Okay? So if we get that, then we're going to process it. If not, we're just going to skip it. Let's see. Let me catch up on chat here real quick. Using Windows libs to get the font kerning, etc., and generating the atlas, I imagine. No, I'm actually not. We have a import process, which actually we're going to be touching on that potentially tonight. We'll see. We have an import process where, in this case, I'm actually using STB TrueType to read the system fonts, because this is cross-platform, right? So it's got to work on Windows, Linux, and Mac. So I use STB TrueType to parse the font files, get the kerning, get all the glyphs, all that kind of stuff. And then I use that to load in all the information that I need in terms of generating all that stuff, and then I'm able to, from there, create all the glyphs and whatnot. What are you allocating with kallocate some default arena? Yeah, so kallocate points to a custom allocation routine that we have set up that allows me to tag allocations as certain things, so that I can actually cordon off sections of my memory for different types of data for data locality. I'm not doing that second part yet, but the tagging system is in place to allow me to do that when I get to it. And then also I can run stats on that and find out, if I've got a memory leak, what type of thing is leaking the memory, that kind of thing. So yeah. Let's see. Do you regret writing such long function names for your object array functions? I just wrote an array library myself and regret making them so long. I mean, yes and no. There are parts of it that I would shorten, but not really. Code completion really just kind of makes it like I could just type the first couple of the first letter or two of each part of the function name, and then, it pops up in a list. I can just hit enter. So it's not really that bad, honestly. You can make aliases for the most used ones. That's true too, if I wanted to. Yep. It is a good lib. Yeah. It's one of the few that we're using. And basically the idea here is that library use is okay for importers and things like that, but I'm not using them at all in the core engine whatsoever, outside of the ones that are required, like OS libraries and things like that, like Windows, like H and the Vulkan, right? But yeah, none of that stuff exists in the core runtime. It's all in our importers and stuff like that, all of our external tooling. So that way when we ship the application, we're not including all that stuff with it. Makes it a little cleaner, I think. Okay. Name a car for an edit. I mean, well, what do you mean by name a car for an edit? Do you just mean like in the car that I have in the scene? I think that's like a Falcon, I think. Okay. So attributes, we're going to go ahead and get that. And then the next thing we need to do is actually extract a attribute count from that. So we need to make sure that that's successful as well. So we'll say if not, KSON array element count get, and we're going to take the address of attributes array, and we're going to save the out or the count to typed asset attribute count. Right? If we fail to get that count, then that means that we have hit some sort of serialization or parsing issue with our actual parser and that there's an issue. So failed to get attribute array count. See logs for details. But I'm going to count that as a general failure to parse the thing. It would be something catastrophic must have gone wrong for that to actually fail, but maybe it'll give us more information, right? So we get the length of that array, which allows us to then set up our typed asset attributes, right? So we can say k-allocate size of k-assets shader attribute times typed assets attribute count, and then we'll tag that as an array, right? So we have that. The next thing we do is we instead of creating an object, we actually need to extract the object, right? So we'll change this to 0 initialized, and then we'll do what is it? Casein array get object. The array is going to be the attributes array. The index is just going to be I, and the object we're going to save it to is going to be the address of attribute object. Right? And so did we actually, yeah, that's fine. All right, so we have that. We have a convenience pointer to the target in this array. And so all we need to do again is convert these from gets, or from adds to gets. So get string, and then type. Again, it's going to be that two-part process. So we're going to have, let's do temp on that, right? And then we'll do the address of temp, rather. And then once we have that, then we'll do typed asset. Actually, we just need attribute, rather. Attribute type equals string to attribute type. And we can pass in temp. And then we can string free temp. And then this is just the name, so we can just use the name directly there. So we want the address of that. We don't need that. We don't need that. And that is parsing our attributes. Relatively straightforward stuff. The fun guy, how's it going? Welcome. Ads, yep, you're right. I did miss the ad timer. Oh well, it is what it is now. That hasn't been popping up for me tonight. All I have is like the ad timeline that's showing up for my preview, but I haven't seen the notifications popping off about when ads are showing up. So I've missed the ad break a couple of times. Okay, so that's attributes. Now uniforms is going to be a little bit different. Not too much different, not too bad. But our uniforms have scope, and the scope is where the actual array is. So the first thing we're going to have to check for is, does the uniforms object exist? And then we'll have to go through each one of these types to see if they exist, because these potentially couldn't. Could or couldn't, right? and if there's the potential also that none of it exists. So that's going to be kind of the way that we're going to do that. We'll go through each type, and then we'll get a count of each type. We're going to have to do that as well, just to figure out how many of each we need to actually create, and then we'll go through and parse them. Okay, so the first thing is we need to casein object get, and we need to say this is from tree.root, and we want to get something called uniforms, right? And we're going to store that uniforms object here, right? So we're going to say address of uniforms object. And again, this is optional, so if we don't find it, it is what it is, right? If we don't find it, we don't do anything. We don't do anything else. So this goes away. We don't actually create these arrays. We are just going to initialize them to 0. So there we go. And then we actually have these counts here. So what we're going to have to do is we're going to get each one of these arrays first. I guess that's the first thing. We'll get those, and then we will address the count situation. Using C89, no. I'm using, technically I'm using C17 at the moment. I do want to, later on, if I can, back that off to C99, but yeah, that's kind of the way that I'm working at the moment. I'm guessing you're asking that because I have all this stuff up here before it's actually used. Okay, so the first thing we need to do is we actually just need, I'm just going to take a copy of this, right? So we're going to handle we're going to do this like this. We're going to say from the uniforms object, we want to select the global array if it exists. This is going to be a case in, oh wait, we already have that up there. So we can just literally do global array, okay? So if we have that, do we actually have, we do have a count. Perfect. So we don't actually have to, we don't have to loop through this and count it. We do have a counter. That's good. So our case array in this case is going to be global array, and the out count is going to be global array, global count, right? So we're going to do that a couple more times. I'm just going to copy pasta this. We're going to do it once for that, once for instance. Instance array, instance array, instance count. And then we'll do local array, local count. Okay? So we've extracted those counts, we've extracted the arrays if they exist. And now what we can do is we're also going to need to keep like a total uniform count. And that's so that we know how much space to actually allocate. So we'll do a, I guess we can actually just keep this on the typed asset. We'll say uniform count equals global count plus instance count plus local count, right? That will allow us to say typed assets uniforms equals kallocate size of kasset shader uniform times typed asset uniform count. And then the memory tag is going to be array. All right. So now all we have to do is essentially just push to that position within the array. That being said, we're going to need to keep two different sort of progresses, right? We're going to have one progress through the uniforms array, or like one index, and then we're going to have to loop through the arrays separately and add them to the uniforms array like that. So we're going to do the globals first, then instance, then local. So what we'll do here is we'll say U32 uniform index equals 0. And we actually don't need all this stuff. Oh, posture check. I appreciate that. My posture was rubbish. Thank you for that. Also, thank you for the follow. Okay, so the only properties we actually have to extract out of these is the name and the type, which is easy. So instead of looping through uniform count, we're actually going to have 3 of these loops. So we're going to do, this one is going to be global count, right? And we're going to do globals first. So uniform object is going to be, it's going to be, let me think about this for a second. It's going to be initialized to 0, right? So we'll just do this. And then we'll do kson array value get object. The array is going to be global array. The index is going to be I. And the object we are going to write to is going to be uniform object. Okay. Now, this uniform convenience pointer is a uniform to this sort of array that contains them all. So we're not going to want to index that by I. We're going to index that by uniform index. Right? And that's just kind of how we're going to proceed through that. And then once we're done down here, we're going to do uniform index plus plus. Okay? So this will just to make this a little bit more obvious as to what's going on, we'll do string get, and this will also be get string. So type, we are going to have to do the parsing thing again, so we want temp for that. Oops, wrong thing there. So we're going to want to pass the address of temp. Okay. And then down here, we're going to say uniform type is equal to string to uniform type, and we're going to pass temp. And then once we're done with that, we're going to string free temp. Okay, and then name is much more straightforward. We just pass the address of name. Okay, so we do that once for the globals, and then we don't need all of this stuff down here. We can get rid of all this. So we do that once for globals, and then we want instance next. So instance count, right? instance array, uniforms objects, uniform index. Okay. And I think that's actually all we need to change. Yes. Okay. So it's that, and then we can do one more. Right, and this is just local. Local count. And we want local array. And there we go. So it takes those out of here, compresses them or flattens them into one array. And we're good. And that's it as far as parsing that file, right? That'll just take care of all of that. And then we are good to go. At the bottom, let's see, do we not have... Yeah, I think the only thing we need to do is clean up. There's no temporary stuff we need to actually handle. So we don't actually need the success bit, I don't think. We don't have any of that to worry about. So actually we do. These guys we do. Okay. All right. So we do need the goto still, but we don't need that. Okay. I think we are done with our serializer, which is awesome. So, I guess let me make sure it builds real quick. All right. Built on the first try, go figure. Okay, so now the next thing that we need to do is we have our serializer written. So now we need to create our asset handler that looks at the serializer, which is not going to be very hard at all. So again, I'm going to use the height map terrain one as a sample and just swap things out. So we'll go into the, let's see, that's going to be in runtime. Runtime, here we go. So source, assets, handlers. And like I said, I'm going to use this, and we're going to do shader. And then I'm also going to grab the C file, shader. So let's open that up, and we're going to do a replace, find and replace on that. That looks pretty good. And then we're going to open up the C file and do the same thing, which is just going to mess up a couple minor things, but no big deal. So it should make sure that our includes are all correct. The only thing I think that it really screws up is this. Because it doesn't maintain casing. Let's see. Other than that, move this off to the side. Okay. The only other thing that we need to handle now is releasing an asset, right? So our serialization is handled by these guys automatically, right? So when we serialize or deserialize, or I should say when we deserialize, we create the asset. So all we really need to do here is just tear down the asset when we release it. So this we'll have to do a little bit manually, but it's not a huge deal, right? all we really need to do is go through, destroy all the strings, and destroy the arrays. And that's basically going to be it. So we want typed assets. Let's see, do we have anything at the top level? No. All right, so we could just pretty much go with the arrays right away. So I'm actually just going to nuke this top segment. And we're going to do, let's do stages first. So stages and stage count. That's going to be stage count. And then stages. And then this is going to be k-asset shader. Oops. K-asset shader stage. And then we want to rename this to stage. Why is this bleating? Oh, because I'm not taking the address of it. Derp. Okay. So that's a pointless check. All we really need to do here is say if stage source asset name string free stage source asset name, and oops, and then do the same for package name, and that's stages, and then we can free stages, and this is going to be stage asset shader stage stage count. So we free that, and then we do stages equals 0 and stage count equals 0. Right? So we basically just repeat this process for, actually it's this whole thing. So we do this again for attributes. Let's get this one down here too. Attribute count. Attribute counts, and then we have shader attributes. And then we have, I think this one only has name. So that's all, oops, that's all we have to worry about there. Let's, I guess, our attribute there. And delete attributes. This is going to be also attributes, and then attribute counts, attribute count. And then uniforms. Uniform counts. Uniform counts. Change this to uniform. Uniforms are going to be the same thing. They only have the one string, which is name, so that's fine. Uniforms. Uniform count. Uniform count. All right, so we freed all of the memory that we need to free in there. to handle that. The only other thing we have to do is register this, and then we're done with this asset type. So if we go to Asset System, if I can type it correctly, and then we'll search for, I guess, height map terrain works. This is what we need here. So we're going to, oh, we didn't include the file up here. Include assets handlers shader. This is going to be shader create for asset type shader, and that's it. It's registered. So that is shader parsing done. The only thing about this that sucks a little bit is that we do have a number of shader config files we're going to have to update. But that's not the end of the world, I guess. If we take a look at what we have to convert, it really is, and I guess I can show you the old version of the format as well. If we do runtime, actually, let me close the source and go into assets shaders. Expand this out. So any of these shader config files are now going to be renamed into this KSC file. Thank you for the follow, Emily Bunny. Appreciate that. Welcome. Okay. So we're essentially going to reformat these, right, and rename them. So we're going to reformat them from this old format to this new format, which most of these shaders are not as complicated as this one. That's the reason I chose this one first, is because it has some of the most properties. So I don't think you guys necessarily need to watch me do that. I can do that offline. It's just going to be a matter of changing the file extension and then reformatting this file to match this, right? So that actually, I've just got a list going here. We have our handler done. We don't need an importer for it because it's just the native type. So actually, let's head over to the to-do file, which is sort of our roadmap, if you will. Let's close this other view. And let's check out our list. So we have, let's see. I thought I had shaders in here. Didn't I add it? Yes, I did. Okay. So we have some other subtasks around shaders that need to be done, but we can't really work on those until we get to the resource half of this. So this is in process. We can't mark that as done, but these two are done. I guess I can't really mark that one as done yet, but it's in process, right? So the ones that we have left to convert, and they're going to work a little bit differently than the way that shaders worked, is we have our bitmap fonts and our system fonts. So we're going to rename the extensions on both of those, and then we're going to essentially just actually, it looks like we're going to have to change the format of the system fonts, but there's not a whole lot of data in there, so that shouldn't matter. I'm not going to reformat the bitmap font file because, in fact, you guys might actually recognize this format. Let's see, where did I think I included that with our standard UI. Yes, okay. So these FNT files look like this, right? So this is how our bitmap fonts work. This comes from the BM font utility made by Angel Code. So you've probably seen this widely used. This is what we're using for our bitmap fonts. No surprise there. But basically we just parse in this data. So all we're going to do is we are going to write a parser for it, but we already have this parser written. So we're going to take that parser and basically just sort of relocate it into our serializer instead. So there's that one, and then there is these font config files, which are what we use for importing TrueType files. So all this really has is a file name, right? Which is going to be probably changed to like asset name. And then it has all the faces of the font that we want to load from it, right? So we just have this indexed here. Also ads. Caught that one this time. Which is good because my voice needs a break. About 45 seconds left on ads. Thank you for the follow. I appreciate that. We're almost done with our ad break. All right, cool. Ads are done. So I'm thinking with the time we have remaining, I think this one would probably be a nice quick one to knock out because we have this example, which is a font configuration file that has multiple faces in it. And then we also have this example, which just has one, right? So it really has only two properties. It's pretty simple. I think we can knock this one out. And we're just going to convert this to KSON format as well. So let me just see. Let me flip back to the to-do here for a second. So for system fonts, we wanted to convert the font config extension to a KSON-based KSF file. But we did talk about we potentially wanted to have like a binary for this one to include it as one sort of file. That's not quick, actually. Okay. So I suppose we could write the serializer. Well, we could write one of the serializers. We can write the import serializer. Let's put that as a separate item here. So we have import serializer, and then we also have primary format serializer. So yeah, I forgot about that other extra step. So there's a couple of things that we need to do in here. We need to convert this, obviously change the extension and convert that to a new file format. We need to write an import serializer for that reads that file format, and then hook that up to an asset handler. That makes sense. That's not going to be too complicated. The other portion of this is we need to make a new binary format for this that basically takes this imported file and takes this file that's included here and reads that in as a binary blob, and then includes that along with any of the information out of this configuration file into a single binary file that can then be parsed by a new primary format serializer. Which that's not going to take a ton of work, but it is going to take a little bit. Yeah, I don't know if I want to jump into that tonight, actually. So I think probably what we'll do is we'll just we'll work on this import serializer a little bit. We'll start there. And we'll also do so this font config file. We're going to rename that. What did we say? We're going to name that to KSF, so for Kohi system font. So we've got that, and then we have this one here, KSF. Right, so we'll rename those, and then we will edit this guy. So all of these comments, essentially, oops, will become like that. File just needs to be quotified, essentially. And we're going to get rid of these fully qualified names, so we're not going to do that anymore. We're just going to do this. We might do something like a folder or something like that in the package. Haven't really decided yet. And then for these font faces, these we're going to convert these comment lines first. And then I think what we're going to do is, instead of having it like that, we're going to do faces equals array. Come down here to the bottom, close that off. That way we don't have that repeated sort of rubbishness all the way down. So we're going to do we're going to have that, and then we'll do close off these strings, and that's it for converting the file format. We're going to keep it nice and simple. So we'll do the same for this guy. Did we? Yeah, okay. So it looks almost the same, but it's just ever so slightly different in how we're going to parse it. So we're going to get rid of the fully qualified name here. And then we're going to do faces equals. And then we're going to move this guy down, turn that into a string, and do that, right? And white space doesn't really matter in this. I could do this, or I could do that if I hated the world. It doesn't really matter. You know what we should probably do? Let's do TTF asset. Let's name that instead of just file. Because this is going to be something that we request through the VFS. So we're going to request it as a binary asset, essentially. Okay, so let's open this over here, and then over here we're going to create the importer serializer, which is not going to live in core with the other serializers. Import serializers live with the utils plugin, because we don't want to include that in our release builds. So we're going to put, let's see, handlers. That's not even under here. It's under, oh wait, I'm under runtime. That's not what I want. I'm under the wrong folder. Importers, here we go. Nope, not importers, rather. Serializers. Okay, so it does meet sort of the same structural requirements. So let me see if I can actually, I think I'm going to once again copy the height map terrain serializer. I'm going to copy both of these, and I'm going to put them here. And I'm going to rename this to Do I want to say system font? We're going to have two of these serializers, right? We're going to have one for the primary system font and one for this sort of config. I guess maybe we'll say KSF serializer. Acorn 1010 with a raid of 67 viewers. Thank you so much for the raid. What are you guys getting up to? How are you doing? What'd you get up to on stream? There's a shout out to Acorn 1010. Give them a follow if you haven't already. And Raiders, I will give you a brief introduction as to what we're doing here. Ruined. You're hating Redux? Nice. Almost 69. Yep. So close. So close. Thank you for the follows, guys. Doing pretty well today. We're doing crazy games integration stuff for our pool game. Sweet. That sounds pretty cool. Thank you for the hydrate redeem, by the way. Okay, so let me give a quick... Oh, you're the creator of Funi.com. That's pretty cool. That's pretty awesome, actually. So what we are working on here is something called the Kohi Game Engine. And what it is we are building a game engine completely from scratch using C and Vulkan as our initial rendering backend. I say initial rendering backend because we do have plans to support Direct3D as well as Metal. That being said, we are cross-platform, so this is available on Windows, Linux, and Mac OS, desktop for now. We do have other platforms planned in the future, such as mobile, like iOS, Android. I'd even like to get this on the Switch at some point. But that being said, this is a game engine that was built entirely on... it started off as a YouTube tutorial series, and now we're building it live on Twitch. So we do build everything here, and the reason is we're kind of building a game engine as sort of a educational resource on a way of building a game engine. It's not necessarily the only way to build a game engine. It's not even necessarily always the right way to do it. Sometimes we deliberately do things the wrong way to understand why it's the wrong way, right? So there's lots of exploration, there's lots of trial and error, there's lots of things that we discuss and try to do. Sometimes the experimental things work out, sometimes they don't. That's the nature of the beast. So I will drop the link here on both sides if you guys are interested in that. This is a completely open source engine. So if you go to that website, you've got all the links here to our Discord, which has got about 1,000 people on it, or almost 1,000. YouTube, Twitch, GitHub link here, Patreon, all that good stuff, even the stream there at the bottom. But if we go to GitHub, I do want to point out that this is a open source, free and open source engine. So it's Apache 2.0 license, which means that you're free to use it however you want, whether it be for personal or commercial, does not matter. All that I ask is that you say that you use Kohi if you use Kohi. And that's literally it. There will never be any sort of licensing fees or royalties of any kind, none of that stuff. It'll always be free and open source. So I'm trying to create basically the resource that I wish I had when I was learning how to do this stuff. So that's more or less the crux of it. That's what we're doing here. And I guess I can run this really quickly because I don't think my code is broken at the moment. So I can actually run this and quickly show off what we have. Oh, I spoke too soon, but I broke something. Okay. I am overhauling the asset system, so that's hardly a surprise. Let's see. Let me clean and rebuild the whole thing, and we'll start from there. I may not actually be able to get it to run. I had it running earlier, but I am overhauling the asset system at the moment, so it may not run. Thank you guys for the follows. I really appreciate that. And welcome aboard. All right, Windows looks like it's doing the thing where the process is hanging again. I really need to like stream on Linux next time. Windows is just being a bananas lately. So let me try it in here. It's entirely possible that I've now broken something, of course, right when, you know, I'm trying to demo it. That's always the best time to break things, is right before you get rated. All right, and looks like everything built successfully. Yep, okay, let's try this again. So move this down here. There it goes. Okay. I guess it just needed a clean and rebuild. So what we're looking at here is what we've built out basically. So this includes not only the renderer but all the underlying systems for like input and stuff like that, right? We're building out a virtual file system right now, packaging system. We're redoing the asset system at the moment. So all this stuff is very much under construction. But what we're looking at here is sort of a testbed application that I put together, like a driver application to test the engine out. So every time that I add a feature to the engine, I could just add some code into this to test that feature. And it's also, you know, sort of serves as our test application or our test harness at the moment. So we recently added the water. We do have a PBR graphics pipeline in it. There's still some things missing from it. We don't have any post-processing or anything like that, but we do have the ability to, you know, load static meshes, as well as we have LOD terrain that's chunked. That you know, is able to be quite large, and that actually this is just a fraction of how large it can actually get. And then we do have the ability to select various objects and manipulate them in the scene. So I can select this car, for example, and I can move it around with a gizmo that we also created from scratch. And we have the ability to, you know, rotate that around if we want, and so forth. That's got a light object attached to it there. I can also scale it if I wanted to and make it, you know, really large or really small. We of course have the required Sponza scene in here, just to test out, you know, how the renderer looks in you know, with this scene. So I think it's looking pretty good. We have cascaded shadow maps, so we have the ability to look at lighting a few different ways, or look at the scene a few different ways. I should say this is the lighting only mode. We have some normals. We have our cascaded shadow maps, which you can see here, the 4 different levels of that. You know, as you get closer, the shadows clarify and so forth. And then we also have a wireframe view as well. So yeah, those are the things that we've done so far. We have a lot more to go, obviously, but that's kind of where we're at. Are those oriented bounding boxes? Yes, they are. Yep. So they will, you know, they move right along with the object themselves, right? So yeah, we wrote all of that logic on stream from scratch too. That was a bit to figure out as far as the you know, the raycast picking and stuff. We do have raycast picking. In fact, actually, you can see here these lines that are generated in the scene are when I actually click something, it shoots out a ray from where the camera is to where that object is, and so you can actually see how that was, you know, calculated in 3D space. So yeah, I'm pretty happy with it so far. There's a lot of stuff that we have to do. A lot more. There's always a lot more, right? But that's where we're at now. We kind of got to a point where like I was about to add another asset type, and I'm like, you know what? Our sort of existing resource system was very ad hoc and just kind of added very quickly and hacky, just to meet the sort of criteria of a tutorial format, which is how this whole thing began, and we sort of outgrew that format. And so there's a lot of tech debt associated with that, because of that was the original way that we did it. And so we're switching from that to actually a proper architecture with things organized the way that they should be. So we're actually switching to asset handlers that have importers of their own, and serializers for all the different asset types, and then different importer serializers versus the native format serializers, binary formats for things, just stuff like that. So that's kind of what we're going through and working on here. This terminal is still hung up. I hate Windows sometimes. I hate Windows all the time, but it is what it is. All right. So what we're doing right now is we've basically gone through my find files is busted too. Great. Okay, so we're basically going through and let me actually I'm gonna have to quit them, I think. All right, so what we're doing here is we've got a sort of roadmap, and this is all the stuff that we're handling for this particular release, and I've got this all worked out in here for all the different types of stuff that we're sort of reworking. And X's are the things that are done, spaces are the things that are not done, and we've knocked out a few of these things tonight. And then this is also available in the repo, this file. So you can see all of these engine general things. These are all things that we've actually done already. And there's quite a few blank ones too, but there's quite a few X's in here. So there's quite a few things that we've actually accomplished. We had a big reorganization in 0.7 as well, so we did a bunch of stuff there. Here is the renderer and some of the things that we have and that we want to do for that, and some of the things that we have done. Things like adding deferred and forward plus rendering, compute shader support, that kind of stuff. Ray tracing eventually, maybe. Different plugins we want to make. All of our UI controls that we want to make, those kind of things. So, we are trying to sort of keep track of what's done versus what's not done, what we want to do, and go from there. All of that said, unfortunately, this is the time I usually end the stream. So that's sort of the introduction to the project, but, I do have work in the morning. I have to get up early, super early in the morning, actually. So with that said, I am going to be ending the stream here, but I do appreciate all the follows, and if you guys haven't followed me already, I would encourage you to do so. And on the next stream, we'll sort of pick up where we left off and continue with our asset redux, as I'm calling it. And we're eventually going to have this reach the other side, which is the resource side, and have the resource side use all of this asset rework that we're doing, and then we're going to Jabify all this stuff, which means we're going to be able to multi-thread it, which is going to be pretty sweet. So lots of cool stuff coming along. This should speed things up a lot to make things a lot easier to work with once we nail everything down. So anyway, that is pretty much going to do it for tonight. So let me find a channel 2 raid. Let's see. I want to find something that is somewhat related to what we're doing. If that's possible. I'm going to have to shrink this list down a little bit. Let's see. All right, let's have a look at trying to find something that's related to what we're doing. It's a little difficult to find at this time, unfortunately. All right, we're going to go with looks like there's somebody that's doing game dev in TypeScript, which is something that I did in the past. So we're going to try rating this chap. All right. And yeah, thank you guys so much for joining me tonight. Again, thank you for the raid. I really appreciate it. And welcome all the new folks. And we will pick up this next time I stream, which may or may not be tomorrow. We'll see. I don't know yet, but we'll see where we land on that. Anyway, thank you guys, and I will catch you guys next time. See ya.